Before the skyscrapers rose, before the first humans set foot in the Americas, the land we now call the United States of America was a world apart. A place where immense, strange creatures, dinosaurs, roamed through dense forests, coastal mudflats, and vast deserts. But this is not just a story about giant creatures. The history of America in the age of dinosaurs is a grand journey spanning hundreds of millions of years, from the formation of continents to fateful extinctions. Our journey begins with a simple yet profound question: what was America like during the age of dinosaurs? To answer this, we cannot simply list familiar species like Tyrannosaurus rex or Triceratops. The story is much deeper than that. It is the story of a planet in formation and flux, a continent once divided by an ocean, a climate that swung between humid tropics and arid deserts, and a bizarre chain of life that dominated the world for tens of millions of years. About 250 million years ago, Earth did not have 7 continents as it does today. Instead, all the land was gathered into a single, giant supercontinent called Pangaea. North America, at that time, was a northwestern part of this landmass. Throughout the Mesozoic era, which lasted about 180 million years, and is divided into 3 major periods, the Triassic, Jurassic, and Cretaceous, the North American plate began to break away, drifting northwestward and carrying with it the initial form of what would later become the United States. As tectonic plates shifted, the topography constantly changed. Mountains rose, plains subsided, and seas advanced and retreated. Great mountain ranges like the Appalachians in the east had formed very early, even before the dinosaurs. Meanwhile, the Rocky Mountains, a majestic symbol of the American West, only began to rise toward the end of the Cretaceous period. These geological changes created a variety of different ecosystems, each a unique piece in the giant puzzle of Earth's history. The weather then was nothing like it is today. The Earth during the Mesozoic was significantly warmer. There was no ice at the poles, leading to higher sea levels. The land that is now Florida was underwater for much of this time. Areas like Kansas and South Dakota, now deep in the continental interior, were also covered by an inland sea. The climate was generally tropical and subtropical, particularly humid during the Jurassic and Cretaceous periods, creating ideal conditions for lush forests to grow and for plant-eating dinosaurs to thrive. In the area that is now Utah, Colorado, and Wyoming, the Jurassic climate and terrain created perfect conditions for the development of giant dinosaurs. The more than 25-meter-long, 82-foot-long, Diplodocus once strode through fern-covered lowlands. Stegosaurus, with its large sail-like plates on its back, fed on low-lying plants in primeval forests. Meanwhile, Allosaurus, the most formidable predator of its time, lurked behind bushes, ever ready to strike its prey. Moving south to the lands that are now Arizona, New Mexico, and Texas, the climate became more arid. Here, during the Triassic period, the first dinosaurs like Coelophysis, a small and agile carnivore, appeared. These dinosaurs lived in a near semi-desert environment where the main vegetation consisted of ferns and low-lying gymnosperms. Fossils found at Ghost Ranch in New Mexico reveal a picture of an ancient ecosystem where Coelophysis once reigned. Meanwhile, the eastern United States, especially the coastal areas of New Jersey and the Carolinas, had thriving mangrove forest ecosystems. Here, paleontologists have found fossils of small dinosaurs, amphibians, and even traces of flying creatures like pterosaurs. The humid climate and numerous swamps made this area an ideal place for fossil preservation. Many specimens are so detailed that imprints of feathers or soft tissue can be seen. The Western Interior Seaway is an indispensable part of America's ancient picture. During the Cretaceous period, this sea split North America into 2 landmasses, Laramidia to the west and Appalachia to the east. This shallow sea stretched from the Arctic Ocean down to the Gulf of Mexico, and was home to a host of ancient marine creatures like Mosasaurus, Plesiosaurus, and giant sharks. Fossils found in Kansas and South Dakota, places that once lay at the bottom of the sea, show that this was an underwater world, every bit as vibrant as the one on land. The biodiversity in America during the Mesozoic era is what makes this region so unique. It wasn't just dinosaurs. Other reptiles, fish, giant insects, primitive plants, and even the ancestors of birds and mammals all lived and evolved here simultaneously. Their traces from fossilized teeth and bones to footprints have helped scientists reconstruct one of the most vivid pictures of prehistoric times. Another important factor that shaped the ecosystems and behaviors of dinosaurs in ancient America was geographic differentiation. When the inland sea divided the continent, dinosaurs in the west and east began to evolve in different directions. This led to high diversity among species groups, with some dinosaur genera found only on one side of the sea. For example, the vast majority of T. rex, Triceratops, and Hadrosaur fossils have been found in the west, the ancient land of Laramidia. Besides the prominent dinosaurs, the ecosystem also recorded the presence of other ancient reptiles like crocodiliforms, the ancestors of modern crocodiles, and large lizards. These faunas coexisted with dinosaurs, competing for food sources or serving as prey. Some special fossils even show evidence of their interactions, like dinosaur tooth marks on ancient crocodilian skeletons. The role of plants in shaping the prehistoric environment cannot be overlooked. Forests of gymnosperms like pines, cycads, and ginkgos formed the foundation of the Triassic and Jurassic ecosystems. By the Cretaceous period, flowering plants appeared for the first time, leading to an explosion of species diversity, from pollinating insects to plant-eating dinosaurs. The advent of flowering plants changed the food chain and led to new evolutionary paths for herbivorous dinosaurs. And a special feature of the U.S. is that many ancient lands are still preserved in their geological strata, becoming a treasure trove for paleontology. The Morrison Formation in the West is a prime example. It is where a series of important fossils such as Apatosaurus, Stegosaurus, and Camarasaurus have been excavated. Meanwhile, the Hell Creek Formation in Montana and North Dakota is notable for its late Cretaceous fossils, especially the nearly complete specimens of T. rex and Triceratops. The journey to discover America in the age of dinosaurs cannot ignore extreme climate factors. There were periods when the climate became unusually arid. Species had to adapt to prolonged droughts, low rainfall, and fluctuating temperatures. Fossilized pollen and petrified tree rings are evidence of these harsh periods, showing that life had to endure many survival challenges to continue evolving. Within modern America, ancient evidence still lies dormant beneath the earth, fossils hidden deep in sedimentary rock layers, fossilized footprints still imprinted on cliff faces, dinosaur teeth emerging from riverbanks after a heavy rain. Each discovery is not just evidence of a single individual, but a piece of a lost world, a place where America had no people, no borders, only wild nature and the magnificent creatures that ruled it. The story of prehistoric America, then, is not merely a list of the dinosaurs that once lived here. It is a journey of discovery into another world, a parallel universe that once existed, a rich and fierce biological cosmos, a testament to the power of time, evolution, and the relentless change on this planet. And all these wonders are still waiting to be revealed, bit by bit, through layers of rock, fragments of bone, and fossil traces scattered across the United States. From the deserts of Nevada to the forests of Montana, from the cliffs of Colorado to the plains of Texas. After the challenging and transitional Triassic period, Earth entered a new era, the Jurassic. This period marked a major turning point in the history of dinosaur evolution. From small, agile creatures, dinosaurs now evolved into colossal beings, weighing tens of tons and standing taller than multi-story buildings. And North America, especially what is now the western United States, became the main stage for this grand presence. Approximately 155 to 145 million years ago, the region encompassing the states of Utah, Colorado, Wyoming, Montana, and New Mexico brought together the ideal conditions for preserving large-scale dinosaur fossils. This geological area, known as the Morrison Formation, is one of the most important and richest fossil beds on the planet. Its layers of sandstone and mudstone are filled with biological remains, bones, footprints, plant fossils, and even entire habitats frozen in time. Imagine a vast, ancient savanna where herds of nearly 30-meter long, 98-foot long, Diplodocus quietly graze on ferns along the banks of an ancient river. These creatures had crane-like necks, thin, whip-like tails, and skulls that were strangely small for their bodies. Each individual weighed about 10 to 15 tons, yet they moved with relative grace thanks to a system of hollow bones and sophisticated biomechanics. Alongside Diplodocus were other giants like Camarasaurus, a herbivorous dinosaur with a larger skull and stronger tooth structure, suitable for chewing tougher plants. Apatosaurus, also known in popular culture as Brontosaurus, also appeared here with a massive body and a tail that could be used as a defensive weapon. In this colossal picture, predators were essential. Allosaurus, considered the apex predator of Jurassic North America, was a powerful bipedal creature, about 8 to 12 meters, 26 to 39 feet, long, with dagger-sharp teeth and good eyesight. Allosaurus fossils are found in great numbers in the Morrison Formation, indicating it was the dominant predator of this era. Some fossil specimens even bear traces of healed fractures, suggesting they lived long lives and may have even hunted in groups for greater efficiency. And that ecosystem, besides the giant herbivores and ferocious predators, there was also the presence of smaller dinosaurs like Ornitholestes, agile and capable of hunting small prey or scavenging. Alongside them were species like Stegosaurus, famous for the row of large bony plates standing upright on its back and a tail full of sharp spikes, which served as a protective shield. Despite its surprisingly small brain, Stegosaurus is an iconic species of the American Jurassic. The Morrison Formation is not just a land of fossilized bones. It is a gateway for modern humans to recreate a lost world. The rock layers allow paleontologists to determine ancient climate conditions. At that time, the region had a semi-arid climate with short rainy seasons, long dry seasons, and a network of rivers meandering through the plains. These rivers were not only a source of water, but also an ecological highway, guiding dinosaur herds to migrate, feed, reproduce, and sometimes, where they became trapped in the mud, to be fossilized forever. Plant fossils are also found in abundance here, from tree ferns and cycads to small conifers. All of this suggests a relatively simple, yet rich, plant system sufficient to support massive populations of herbivorous dinosaurs. Interestingly, the tooth structure of species like Camarasaurus shows they could chew plants thoroughly, a significant evolutionary step that helped them digest more efficiently. Another special point is the fairly clear evidence of dinosaur social behavior. Fossilized egg clutches, nests of young dinosaurs, and concentrated trackways suggest that some species lived in herds, possibly migrating together, caring for their young, and protecting each other from enemies. Discoveries in Wyoming and Utah show a distribution of individuals by age, meaning the herds had a primitive social structure. Beyond its scientific significance, the Morrison Formation also played a huge cultural role in the history of American archaeology. In the late 19th century, it was the battlefield for a fossil race between two famous paleontologists, Othniel Charles Marsh and Edward Drinker Cope, a conflict known as the Bone Wars. They competed to find, name, and publish new dinosaur species, propelling American science into a golden age of paleontology, with over 70 dinosaur species found, many of which were first discovered in America. The Morrison Formation is truly the Garden of Eden for North American dinosaurs. This is not just a land of giants, but a place that holds thousands of stories of life, struggle, and a grand evolution that span tens of millions of years. While the Morrison Formation largely presents a vivid picture of a world of giant herbivores and formidable predators, the rest of the Jurassic in North America offers many other surprises. One of the most important but often overlooked factors is the geological change and how it reshaped not only the landscape, but also the course of evolution. During the Jurassic, North America gradually separated from the supercontinent Pangaea. Tectonic plate activity caused uplift in the west and subsidence in the center. As a result, floodplains, ancient riverbeds, and coastal lowlands expanded, creating ideal conditions for sediment accumulation. It was these sediments that would later become precious fossil beds. While the Morrison Formation takes center stage, many other areas in the U.S. have contributed significantly to clarifying the Jurassic picture. In Montana, rock layers of the Sundance Formation record scenes of an inland sea that once flooded the land. Marine fossils such as ammonites, ancient sharks, and marine reptiles reveal a rich underwater ecosystem. This shows that during this period, a large part of modern America was an interface between land and sea, creating conditions for parallel evolution between terrestrial and aquatic life. In addition, coastal forest ecosystems have been found in the layers of the Entrada sandstone stretching from Utah to Arizona. These are remnants of fossilized sand dunes once covered by ancient vegetation and dinosaur footprints. These tracks, preserved in the red sandstone, paint a story of creatures wandering across a damp desert at dawn, leaving their marks in the wet sand before time turned them into fossils. One of the most important discoveries from the Colorado region is evidence of interaction between species. In a fossil site near Dinosaur National Monument, an Allosaurus fossil was found alongside the bones of many large herbivorous dinosaurs, but most notable were the bite marks, suggesting that Allosaurus may have scavenged, not just hunted live prey. This opens a new perspective on the behavior and survival strategies of predators during this period. Paleontologists have also begun to use modern technology to study fossil bones, such as CT scans and stable isotope analysis, to determine the lifespan, growth rate, and even the biological cycles of Jurassic dinosaurs. The results show that many species like Apatosaurus could live up to 80 years, while Allosaurus reached maturity in less than 20 years. These data help reconstruct a vivid picture of an individual's development from hatching to biological peak. Not limited to its sheer scale and biodiversity, the Jurassic in North America was also a period of prolonged ecological stability. For nearly 10 million years, major ecosystems remained largely unchanged. This allowed dinosaur species to grow to massive sizes, optimize their biological functions, and maintain large populations. It was also one of the rare periods when large animals dominated the entire food chain without competition from mammals. However, even within this stability, silent changes were brewing. New species began to appear with better adaptations, such as longer necks, larger teeth, and more optimal egg structures. This change did not happen suddenly but quietly. Yet step by step, it set the stage for the transition to the Cretaceous period, where dinosaurs would evolve into the most magnificent and diverse creatures in Earth's history. In geological and biological history, few periods have left as much of a legacy as the Jurassic in North America. From giant fossils and delicate traces to dramatic fossil wars, all have contributed to writing a brilliant chapter for this planet. And today, when you step into a natural history museum in the U.S. and look up at the giant skeleton of a Diplodocus or an Allosaurus, remember that it's not just bone, it's time, geology, and life, petrified over hundreds of millions of years, to tell us a story that is silent, yet haunting. If the Morrison Formation was the epicenter for the colossal skeletons of herbivorous and predatory dinosaurs, then the entire American West during the Jurassic period was truly a complete ecosystem. A place where not only giants existed, but also ancient forests, rivers, valleys, and intertwined life cycles created a prehistoric living paradise. For much of the Jurassic, the area that is now Utah, Colorado, Arizona, New Mexico, and southern Wyoming was not the arid desert it is today, but rather a subtropical region, seasonally humid, with dense forests of cycads, ferns, conifers, and other gymnosperms. Layers of basalt and sedimentary rock formed a fertile foundation where plant life thrived. These forests were the giant dining table for Diplodocus, Camarasaurus, and many other herbivorous dinosaurs. From fossilized plant samples excavated at the Morrison Formation and adjacent members like Brushy Basin and Saltwash paleobotanists have reconstructed the structure of the primeval Jurassic forest. The lower canopy consisted of a carpet of ferns and ancient mosses. The middle layer was composed of cycads and low-lying gymnosperms, and the upper layer was made of conifers with dense foliage. In such an environment, herbivorous dinosaurs not only ate plants, but also moved between forest layers to find suitable food according to the season. Imagine a rainy season morning about 150 million years ago. The ground is still damp with night dew, and a Stegosaurus slowly moves through the dense forest, nibbling on young fern shoots growing along a ravine. High above, a herd of Camarasaurus gently grazes on the leaves of a cycad tree, eating while staying alert to the sounds echoing from a distance, possibly the roar of an Allosaurus on the prowl. The Jurassic forest was not only a source of food, but also a place for shelter, reproduction, and concealment. Studies in the Utah area have discovered traces of dinosaur egg nests built among fossilized tree trunks, indicating that some species chose the dense forest as a place to give birth, using the canopy to shield against enemies and regulate the temperature for their eggs. Besides vegetation, the riverside forest environment also records the existence of other faunas. Fossils of ancient crocodiles, frogs, and some forms of aquatic reptiles have been found in the rock layers of Colorado and Arizona. These creatures lived in the swamps and winding streams under the forest canopy, playing a role in ecological balance. They were food for smaller carnivorous dinosaurs while also competing with them for resources. Another interesting aspect is the soil composition. Analysis of petrified soil layers in the geological strata of this region reveals high levels of montmorillonite clay, a type of clay that retains water well. This explains why vegetation grew so vigorously and why dinosaur footprints, especially those imprinted in mud, are so well preserved. Areas like Dinosaur Ridge in Colorado still have intact trackways hundreds of feet long, where ancient stream banks or swampy forests once existed. The Jurassic forest was not just a backdrop, it was a main character in the ecosystem. Changes in vegetation led to changes in the tooth, neck, and leg structures of herbivorous dinosaurs. As trees grew taller, long-necked dinosaurs like Brachiosaurus evolved to be taller to graze on the canopy. When vegetation became sparser and lower, species like Stegosaurus and the agile, low-bodied Dryosaurus became more common. Notably, some paleontologists also suggest that the multilayered structure of the dense forest led to the evolution of dinosaurs with more complex survival strategies. Moving in herds for mutual protection, choosing feeding times to avoid clashes with other species, or even living seasonally, migrating when the rainy season ended, the forests of the American West may be gone today, but underground, they still exist. Fossilized as petrified tree trunks, buried pollen grains, footprints on ancient mud, and skeletons lying tilted within rock layers. Each fossil is a slice of time, telling us a chapter in the long story of life. Therefore, studying the Jurassic forest is not just about studying trees. It is about studying how the Earth created a complete ecosystem, with light, water, soil, climate, and life intimately connected. And amidst it all, dinosaurs were not solitary rulers, but a link in the densest, most vibrant, and resilient biological network in the planet's history. As we delve deeper into the ecosystem structure of the Jurassic forests in the American West, a special point becomes clear. The forest was not just a habitat, it was an evolutionary engine. Under the shade of ancient trees, dinosaurs constantly adapted and transformed, reflecting the slow but steady changes in the planet's climate, geology, and life cycles. One of the most prominent discoveries is the link between forest type and the social behavior of dinosaurs. In dense forests, poor visibility forced herbivorous species to live in herds for defense. Herds of Diplodocus stretching a dozen strong, moved in single file, leaving behind regular tracks like a marching column. Many such trackways have been discovered at the Pertori River track site in Colorado, dubbed the Paleontological Highway for dinosaurs. Not only footprints, but organic sediments in the rock layers also record leaffall seasons, flash floods, and even ancient forest fires. The remnants of burnt forests have been discovered in layers of fossilized volcanic ash in Arizona, revealing that nature back then was not always peaceful. The Jurassic forest was a place where natural events occurred regularly, and it was these events that created natural selection pressure, forcing dinosaurs to develop diverse survival skills. In particular, many fossils of small dinosaurs like Ornitholestes or Ophniosaurus show signs of evolution adapted to a life hidden under the canopy. They had light skeletons, flexible claws, and large eyes, and may have been active at dawn or dusk when the light filtering through the forest was softest. This opens the hypothesis that some small dinosaur species could have been the ancestors of arboreal or semi-arboreal creatures. Alongside the dinosaurs were countless smaller creatures, fossilized insects, spiders, beetles, and even parasitic ticks. Under a microscope, ancient amber pieces found in Wyoming and Utah reveal a microworld, where insects flew among ancient leaves and flowers, contributing to plant pollination, maintaining nutrient cycles, and serving as prey for other small creatures. Another surprising detail is the existence of ancient fungal networks in the fossilized soil layers. Ancient mycelium threads were found alongside petrified roots, showing that the symbiotic relationship between plants and fungi has existed for hundreds of millions of years. Fungi not only decomposed dead plant matter, but also provided nutrients to living trees, forming the foundation for the sustainable growth of the Jurassic forest. Modern simulations of the Jurassic climate show that the American West experienced distinct dry and rainy seasons, similar to today's tropical monsoon climates. This explains why many fossils are found in layers of soil washed in by heavy rains and then buried suddenly, leading to perfect preservation down to the smallest detail. Intact dinosaur skeletons with soft tissue impressions like skin, muscle, and even internal organs have been found at sites like Como Bluff or the Cleveland Lloyd Quarry. Within these forests, biological stratification was also very strong. Large species like Apatosaurus operated in the upper canopy, while smaller species like Dryosaurus moved only on the ground floor. This created a vertical distribution of resources, helping to reduce competition and optimize the use of living space. All of this proves one thing: the Jurassic forest was not a static scene. It was a living, constantly moving system, where time left its mark in every layer of soil, every tree ring, every fossil. And in that picture, the dinosaur was not merely the main character, but the result of millions of years of resonance between geology, climate, vegetation, and life. Today, when we see the pine forests of Colorado or the red earth of Utah, it can be hard to imagine that this place was once home to lush, humid forests where dinosaurs lived, migrated, reproduced, and died. But it is that very imagination, supported by science, archaeology, and creativity, that helps us better understand Earth's past. And through that, we can see that every fossil, every petrified tree trunk, every footprint in stone is not just historical evidence. They are a whisper from the past, reminding us how great, magnificent, and vibrant nature once was, right on the very land we now call America. As dawn lightly grazed the dense canopies of the Jurassic, a world of pursuit and survival emerged from behind the hazy mist. If the previous chapters were a symphony of plants, herbivorous dinosaurs, and fertile lands, then this chapter unveils the rest of that symphony, a fierce and sharp movement. Where carnivores held the balance of life and death and the land that is now the American West, about 150 million years ago, the food chain was dominated by Allosaurus, the apex predator of the Morrison Formation ecosystem. Reaching up to 12 meters 39 feet in length and weighing around 2 tons, Allosaurus was one of the largest carnivorous dinosaurs of its time. But it wasn't just its size, but its agility and hunting strategy that made it the ruler. The skull structure of Allosaurus shows it could open its jaw incredibly wide, almost forming a 90-degree angle, like a biological hatchet that would strike a powerful blow into its prey and then retract, rather than biting and holding on like many other predators. Fossils with Allosaurus bite marks have been found on the bones of Stegosaurus, Camarasaurus, and even smaller carnivores, indicating it was ready to attack any creature that entered its sights. The social behavior of Allosaurus remains a mystery. Some evidence suggests they may have hunted in groups, a rare trait among carnivorous dinosaurs. At the Cleveland Lloyd Quarry, dozens of Allosaurus skeletons were discovered crowded into a small area, along with the fossils of their prey. Was this a natural trap that ensnared an entire pack? Or is it evidence that Allosaurus lived in groups? The question is still open, but it points to the complexity in the behavior of ancient carnivores that it wasn't just Allosaurus. The carnivorous world of the Jurassic was much richer. Species like Ceratosaurus, with its characteristic horn on its nose, were smaller but agile, possibly solitary hunters or specialized scavengers. Torvosaurus, another large bipedal dinosaur, was considered a direct competitor to Allosaurus in some southern parts of the Morrison Formation. The tooth and skull structure of Torvosaurus suggests it had a powerful bite and the ability to attack thick-skinned prey. At the same time, the skies of North America were not just where the wind blew through the forest canopies, they were the playground of the first flying creatures in Earth's history, the pterosauria. During the Jurassic, pterosaurs like Rhamphorhynchus and Dimorphodon began to appear. Although not dinosaurs by biological classification, these flying creatures played a vital role in the ecological chain. Rhamphorhynchus, with a wingspan of about 1 meter 3.3 feet and a long arrow-shaped tail, typically lived near lakes, rivers, or swamps, where it could glide over the water surface to catch fish. Its hooked teeth and long beak made it easy to snatch slippery prey. Its fossils have been found in Germany, but specimens have also appeared in North America, particularly in ancient rock layers in Colorado. Interestingly, pterosaurs had very light, almost hollow bone structures, helping them fly easily but also making them very fragile. Thanks to special geological conditions, fine mud, volcanic ash, many pterosaur fossils in America have been wonderfully preserved, some even with the shape of their wings intact. Along with the predators on land and in the air, the Jurassic also witnessed the emergence of aquatic predators. Although North America was not yet split by an inland sea, as it would be in the Cretaceous, there were still many large lakes, swamps, and vast ancient river systems. Here, carnivorous fish like lepidotes and hybodontid sharks, ancestors of modern sharks, reigned. Some aquatic reptiles like the Crocodilomorpha, distant ancestors of modern crocodiles, also thrived in the swamps and rivers of the Jurassic. While not dinosaurs, they served as mid-level predators, controlling the populations of smaller animals like fish, amphibians, and young dinosaurs that end this combination of land, water, and sky. The Jurassic created a three-dimensional ecosystem, where each predator occupied a different spatial tier. On the ground, Allosaurus roamed through the forests. In the sky, pterosaurs soared, hunting for fish. Under the water, the shadows of ancient sharks and crocodiles lurked, awaiting their chance. Every hunt was a thrilling chapter in the symphony of life, and it was these interactions between predator and prey that drove evolution, causing species to become faster, smarter, and stronger. That is the harshness, but also the primal beauty of prehistoric nature, which today, thanks to fossils and scientific research, we can begin to appreciate. The ecological balance of the Jurassic was maintained not only by the number of species, but also by an astonishingly diverse range of hunting strategies. A key feature of ancient ecosystems was the ability to adapt to different living conditions, from flooded valleys and low-lying forests to treacherous cliffs. It was these complex terrains that created natural arenas, where the strongest was not the biggest, but the one who adapted the fastest. In the swampy areas along ancient rivers, there were species like Marchosaurus, a medium-sized carnivore about 4.5 meters 15 feet long. Not as grand as Allosaurus, but with a light frame and long hind limbs. Marchosaurus may have been a specialist at stalking prey from low vegetation and launching lightning-fast attacks. It might have been a rival to smaller species like Dryosaurus or a real threat to the eggs and young of large herbivores. Meanwhile, small and agile species like Ornitholestes seem to occupy ecological niches in the dense forests. Studies suggest they may have hunted large insects, lizards, and possibly even early primitive birds. Notably, their relatively large brains compared to their body size are a sign that cognitive development had begun to emerge in some small carnivores from this period. In terms of survival strategy, not all predators relied on speed or strength. Some chose tactics of ambush and camouflage. Geological evidence indicates that some species lived on the edge of semi-arid regions, using skin colors that blended with their environment, such as red sand, mountain rocks, or decaying leaves. While no soft tissue fossils have confirmed their actual colors, analysis of melanosomes from ancient birds, descendants of dinosaurs, allows for speculation that some predatory dinosaurs may have had dark, striped, or spotted plumage for better concealment. At the same time, in areas with waterlogged limestone geology like modern-day Fossil Lake, a completely different ecosystem existed. Here, the predators were not dinosaurs, but large carnivorous fish like the Semionodidae, along with ancient amphibians and turtles. perfectly preserved specimens show sophisticated food webs, where predatory fish could be eaten by a larger fish, creating a continuous layered chain. Another highlight of the predatory chain during this period was the relationship between carnivores and specific terrains. In the rocky outcrops rising amidst the forests, like the slopes of the Morrison Formation, large pterosaurs like Pterodostro or similar genera may have perched on cliffs and swooped down into the water to hunt fish. Modern mathematical models help reconstruct the flight patterns and wing angles of pterosaurs, showing they could launch into the air from the ground, something scientists previously thought was impossible. The presence of carnivores also indirectly spurred the development of defensive mechanisms in other creatures. Stegosaurus likely evolved its spiked tail, called a thagomizer, to counter Allosaurus. Large sauropods like Camarasaurus may have developed herding behavior or protected their young by forming a circle when attacked, much like elephants today. These behaviors were not random, but were direct results of relentless predatory pressure. Besides biology, behavioral trace fossils such as footprints, bite marks, and drag marks in mud allow scientists to vividly reconstruct ancient chases. For example, at Dinosaur Ridge near Denver, Colorado, Allosaurus tracks are found parallel to and interspersed with sauropod tracks, suggesting a hunt may have occurred. No kill was found at the site, but the tracks left behind reveal a silent story, like slow-motion frames from the past. And of course, in this grand picture, time remains a silent but essential character. For millions of years, these adaptive predator-prey relationships continue to play out, one cycle after another. The Jurassic ecosystem was not static, it was a relentless current of natural selection where every species had to innovate or be left behind. Today, when we look at the fossil of an Allosaurus tooth or the petrified wing of a pterosaur, we aren't just seeing an ancient specimen, we are looking at the remaining pieces of an era where life was written in speed, fangs, and flight. And it was these predators, through their ferocity, intelligence, and adaptation, that laid the foundation for the biodiversity the Earth inherited and still possesses today. If the Jurassic was the chapter of nascent giants, then the Cretaceous period was the most magnificent epic in the history of dinosaurs on American soil. It was a world where an inland sea split the continent, where dinosaurs not only dominated the land, but also diversified with unprecedented shapes, sizes, and survival strategies. From the dense forests of Montana to the arid deserts of Texas, this period marked the pinnacle of evolution and also carried a whisper of the end. About 100 million years ago, an extraordinary geological phenomenon began to take shape, the Western Interior Seaway, a vast inland sea that split North America from the Gulf of Mexico to present-day northern Canada. Under the influence of tectonic plates, the ocean rose and submerged the Central Plains, creating a marine ecosystem stretching over 3,000 kilometers, about 1,860 miles. Two land masses were separated, the western portion called Laramidia and the eastern portion Appalachia. Laramidia, corresponding to today's Pacific Coast Strip, became one of the most spectacular stages for dinosaur evolution. Along this narrow landmass, ecosystems from north to south varied widely. Humid rainforests, coastal swamps, dry grasslands, rugged mountains, and semi-arid deserts. Each environment spurred dinosaurs to evolve in unique directions that in the north. Montana, Wyoming, Alberta, the climate was cooler with primeval eucalyptus forests and wet lowlands. This was the kingdom of species like Maiasaura, Pachycephalosaurus, and the ankylosaurs, armored dinosaurs with tails like steel clubs. The fossils found here, especially in the Hell Creek and Two Medicine formations, are not only complete, but also reveal herd lifestyles, social organization, and even parental care behaviors. Heading south to Utah, New Mexico, Texas, the landscape became more arid with red sands, rocky valleys, and scorched plains. It was here that colossal beasts like Alamosaurus, a sauropod up to 30 meters, 98 feet long, crushed the ground with heavy footsteps. Alongside it were Cretaceous, Parasaurolophus, and countless other duck-billed dinosaurs that lived in herds, forming enormous migratory groups crossing the hotland in contrast to the diverse western landmass. Appalachia in the east, the region of modern-day Georgia, Alabama, Mississippi, was a separate, more isolated world. Fossils here are rarer but show the existence of independent species like Aplychosaurus, a predator similar to T-Rex but smaller, having evolved separately due to millions of years of geographic isolation. However, the most outstanding feature of the Cretaceous in America was not just its topography, but its extraordinary biodiversity. This was the period when dinosaurs reached their evolutionary peak, not only in size, but also in life strategies. The Hadrosauridae, the family of duck-billed dinosaurs, became the dominant species of the ancient plains, with dozens of smaller branches adapted to each environment. Their fossils are densely packed from Canada to the southern United States. One of the most notable highlights is Parasaurolophus with its long, backward-curving crest, possibly used to create sounds for communication within the herd. Modern sound modeling reconstructions suggest the sound produced was similar to a low-pitched saxophone, which could travel for kilometers through the dense forest, and one cannot forget the carnivorous dinosaurs, among which Tyrannosaurus rex is the most famous. But before T-Rex appeared at the end of the Cretaceous, a host of other predators reigned. From the agile Deinonychus and the tactical Dromaeosaurus to new genera like Bistaheversur in New Mexico, each species possessed its own unique adaptations, from sharp claws and superior vision to skull structures designed for an extremely powerful bite. The sky was no less vibrant. Pterosaurs like Quetzalcoatlus, the largest flying creature to have ever existed, with a wingspan of over 10 meters 33 feet, soared over the coastal plains. Their fossils are found in Texas, which was once a coastal region of the inland sea. Despite their large size, their light bone structure helped them take off easily, possibly launching with all four limbs like a giant bat. The western interior seaway was also home to underwater monsters: Mosasaurus, Plesiosaurus, Elasmosaurus, giant marine reptiles with sharp teeth preying on fish, ammonites, and even each other. These creatures were once the terror of the ancient oceans. We are standing in the midst of an era where every form of life flourished, from giant insects, the first flowering plants, ancient bees, and primitive birds, to flying dinosaurs, aquatic dinosaurs, and the rulers of the land. This period was not just a biological peak, it was the final, glorious moment before a cataclysm brought it all to an end. The Cretaceous period was not just a symphony of biodiversity, but also a time that shaped revolutionary evolutionary milestones, especially the emergence and vigorous development of flowering plants. Before this, the dominant plants were mainly ferns, pines, and other gymnosperms, which grew slowly and were pollinated by the wind. But in the mid to late Cretaceous, angiosperms, flowering plants, began to appear and spread, opening a new era for terrestrial ecosystems. Plants like ancient magnolias, sycamores, and ficuses appeared with colors and fragrances to attract pollinators. This was also when insects evolved dramatically from butterflies and bees to beetles. They were not only intermediary links for pollination, but also became a food source for small dinosaurs and early birds. The symbiotic relationship between flowering plants and insects helped to further enrich the Cretaceous ecosystem. The skies, primitive birds began to appear more distinctly, differentiated from dinosaurs by their light feathers, sternum structure, and the shortening of their tails. Species like Ichthyornis, with teeth and wings similar to modern seabirds, along with Hesperornis, an ancient diving bird that lived underwater, marked the faint but crucial boundary between dinosaurs and modern birds. Fascinating discovery is fossils showing that primitive bird nests had a very deliberate structure with eggs arranged in an arc, indicating that protective and incubating behaviors existed tens of millions of years ago. The development of birds was not just an inheritance from dinosaurs, but a revolutionary transformation for modern biology. Geologically, tectonic plates continued to push up the western landmass, forming young mountain ranges like the severe orogeny, the precursor to today's Rocky Mountains. This topographical uplift caused changes in climate, hydrology, and biological distribution. New rivers were formed, forests appeared where seas once were, and the movement of organisms between regions became more dynamic than ever. In these forests, armored dinosaurs like Ankylosaurus and Nodosaurus quietly grazed on leaves and took shelter from predators. Their thick armor, like that of a warrior, and a tail that could break an opponent's bones were effective self-defense weapons in a dangerous environment. Their fossils have been found nearly intact, allowing scientists to accurately reconstruct their muscles, scaly armor, and even potential coloration through melanosome structures. Meanwhile, predators became increasingly sophisticated. Species like Truden, with the largest brain of all dinosaurs relative to body size, suggest that intelligence may have developed earlier than we thought. Truden had serrated teeth, large eyes, and the ability to hunt at night, a symbol of evolution toward superior tactics and senses. This diversity is further reinforced by fossilized footprints and behavioral signs such as nests, drag marks, or even fossilized droppings, coprolites. This evidence not only speaks to their presence, but also tells the story of how they lived, interacted, and migrated. The Cretaceous also witnessed the formation of multi-level animal communities, meaning that within the same ecosystem there were biological tiers from plants, insects, small reptiles, and birds to herbivorous dinosaurs, carnivorous dinosaurs, and aquatic and flying creatures. Each of these tiers interacted with and influenced one another, forming an extremely sophisticated and sustainable biological network. However, the beauty of this period was like a brilliant sunset before darkness falls. None of these creatures knew that an asteroid was heading toward Earth, an event that would shake the entire ecosystem and put an end to this glorious era. But in that moment, amidst the ancient forest's mysterious swamps and open skies, life was still abundant, evolution continued, and the America of the dinosaurs was a symphony unparalleled in the planet's history. If fossilized bones are the remnants of the body, then fossilized footprints are the lingering traces of the soul, every step, every leap, every chase, or even a moment a herd of dinosaurs paused to rest in an ancient swamp. These special fossils, called ichnofossils, do not record physical shape, but rather behavior, something that helps us understand the real lives of dinosaurs millions of years ago more deeply. Across the United States, from Texas to Utah, from Colorado to Connecticut, hundreds of sites with fossilized footprints have been discovered. But perhaps the most famous is the Glen Rose Formation in the Paluxy River Valley, Texas. Here, the river has exposed a series of trackways tens of meters long, imprinted on limestone. Enormous three-toed tracks identified as belonging to carnivorous dinosaurs like Acrocanthosaurus, as well as rounder, thicker footprints belonging to herbivorous dinosaurs like Sauroposeidon. Paleontologists don't just count the number of footprints, they also measure the distance between steps, the depth of the impression, the angle of the stride, and the relative positions of individuals. From this, they can reconstruct an entire prehistoric film clip, a herd of sauropods moving slowly in single file with the young surrounded by adults. This arrangement reveals a moving truth. Dinosaurs had social behavior, knew how to protect their young, and had herd organization, something previously thought to exist only in mammals. Besides Glen Rose, Dinosaur Ridge in Colorado is also a treasure trove of footprints. Here, on a sloping mountainside, parallel trackways have been found stretching for hundreds of feet, belonging to herbivorous ornithopods and predatory theropods. Notably, some tracks even show a chase, where the distance between steps suddenly increases, the direction changes, and there are signs of slipping, all as if recreating a tense hunting scene. An interesting question arises. How can footprints be preserved for tens of millions of years? The answer lies in special geological conditions. When a dinosaur walked across a soft mud flat by a lake or swamp, its weight created an impression. If that mud was then covered by a new layer of sediment, for example, sandy mud, volcanic ash, or fast-drying clay mud, then these impressions would be sealed and harden over time. Millions of years later, geological uplift or erosion can expose them to the surface. Like pages of a diary suddenly opened in Utah, the Mill Canyon track site near Moab is another fascinating location. It records the footprints of at least 10 different dinosaur species, from three-toed theropods and heavy, round sauropods, to even the tracks of armored ankylosaurs with their more reptilian gait. From this, scientists have determined that this area was once a coastal plain, a place where various dinosaurs gathered to drink, feed, and mate. Another lesser-known but incredibly valuable type of ichnofossil is the fossilized egg and nest. Discoveries in Montana and South Dakota show that some species, like Maiasaura, may have built nests in shallow pits in clusters of dozens. each nest containing 10 to 20 eggs. In some cases, the fossils have even preserved the embryo inside the egg, revealing the early development process of dinosaurs similar to that of modern chicken embryos. Fossilized nests also speak to parental care, as the bones of young individuals at various stages of development have been found in the same nest. This suggests that dinosaurs did not abandon their eggs after laying them, like crocodiles do, but may have nurtured their young for an extended period, a behavior previously attributed only to birds or mammals that eye. In addition, scratch marks, claw marks, and even coprolites, fossilized dung, are also pieces of the puzzle that help reconstruct behavior. A giant coprolite found in Canada contains bone fragments, proving that a large carnivorous dinosaur digested bone, not just tore flesh. Meanwhile, a series of long, deep claw marks cutting across a rock layer in New Mexico is believed to be a sign of a territorial battle, where two adult dinosaurs fought for control of a watering hole. All of these pieces, from footprints to scratch marks, give us a vivid perspective on a lost world. They are no longer inanimate skeletons, but living creatures, running, eating, protecting, fighting, loving, and above all, they remind us that behavior, something inherently fragile and ephemeral, can leave a more lasting impression than the body itself. As these ancient behavioral traces are gradually unearthed, researchers not only resurrect the image of dinosaurs, but also begin to ask deeper questions about their intelligence, emotions, and social nature. For example, at an archaeological site in Wyoming, scientists discovered a long drag mark, not a footprint, indicating that a large dinosaur may have collapsed on the slippery mud, struggled, and then got back up. These slips and scrapes record accidents, collisions, and even life-or-death moments, not just ordinary movement. Another fascinating aspect is the evidence of migratory behavior. In many places in North America, trackways of the same species have been found hundreds of kilometers apart with similar directions of travel. This suggests that some species, especially herbivores like hadrosaurs, may have migrated seasonally in search of food, water, or ideal breeding grounds. This is similar to African elephants or Arctic caribou today. Dinosaurs may have traveled hundreds of kilometers each year, crossing complex terrain along fixed routes over many generations. Behavioral traces also lead us to less thought of actions like play. A strange series of footprints in Arizona shows a small theropod moving in a spiral pattern, spinning and suddenly accelerating, with no signs of hunting or threat. Some paleontologists suggest it could be play behavior or simply a juvenile running around for fun. If true, this poses a bold hypothesis. Dinosaurs had emotions, complex social behaviors, and perhaps even knew how to enjoy life. Not limited to terrestrial behaviors, some ichnofossils also reveal underwater secrets. In Montana and Kansas, fossilized swim tracks have been found, where a dinosaur only touched its claws to the bottom mud while swimming. These traces are not complete like regular footprints, but are parallel, elongated streaks, only possible for species with sharp claws and long legs like theropods. From this, we understand that dinosaurs didn't just walk, run, and fly. Some species also knew how to swim, at least to a limited extent. One of the most moving pieces of evidence of dinosaur behavior comes from overlapping footprints. At a site near the Dakotas, a series of small footprints was discovered imprinted over a larger track. After analysis, researchers concluded that a young dinosaur had walked exactly in its mother's footsteps, an incredibly powerful sign of family bonds. That scene, though fossilized, still evokes empathy. In a vast ancient wilderness, a young one stuck close to its mother step by step. Today, technology helps us understand these stories better. By using 3D scanning, AI motion simulation, and even deep learning to analyze millions of footprint samples, scientists can reconstruct not only the shape, but also the posture, speed, movement habits, and behavioral patterns of each species. Simulation models show how dinosaurs turned when encountering obstacles, how they moved in herds, or how they evaded predators. The combination of classical science and modern technology has transformed these small traces, once overlooked, into a doorway into the soul of the dinosaur. The things that cannot be seen with the naked eye, such as the motivation for actions, moods, and survival strategies, gradually emerge through every centimeter of ancient rock. More than just their majesty, these traces teach us about connection. Each footprint is an untold story. Each egg nest is a message from the past. And when we connect hundreds of these stories, we not only build a map of behavior, but also find a reflection of ourselves in it as we, too, walk, love, protect, fight, and leave our own marks on this world. Dinosaur footprints are not just paleontological traces, they are the petrified memories of life. And in every trace that fades with time, the footsteps of the creatures that once ruled this planet still echo. In the journey to trace the history of dinosaurs on American soil, there's one group of creatures that always stands out as gentle giants, the herbivorous dinosaurs. Though they lacked sharp teeth or lightning-fast hunting speed, they possessed sustainable life strategies, marvelous body designs, and an indispensable ecological role in the natural systems of the Cretaceous period. And as we step into the world of the hadrosaurs, ankylosaurs, and triceratops, we understand that greatness comes not only from predation, but also from the ability to survive and adapt. First, let's stop in the wild plains of Montana, where fossils of hadrosaurs, also known as duck-billed dinosaurs, have been discovered in large numbers. This species was widespread across North America and was one of the most common and successful herbivorous dinosaur genera. What made hadrosaurs so special was not just their shape, with a flat, duck-like beak used to strip leaves, but also their unique dental structure, hundreds of small teeth arranged in a conveyor belt-like band, which could be continuously replaced, helping them grind tough vegetation. The Two-Medicine Formation in Montana, archaeologists discovered fossils of Maiasaura, a hadrosaur species famous for its nurturing behavior. Fossilized egg nests, containing both embryos and the bones of young at different developmental stages, show that Maiasaura not only laid eggs but also remained at the nest to care for its young, a major step in behavioral evolution. The nesting sites were concentrated in large clusters, suggesting these species lived in large herds, possibly numbering in the hundreds, and migrated seasonally in search of abundant food sources. Meanwhile, in the flatter lands of South Dakota and Wyoming, the petrified statues of Triceratops, the three-horned dinosaur, still hold their heads proud through millions of years. With two large horns above its eyes, a nasal horn, and a frill like a shield, Triceratops was not only striking, but also one of the best defended herbivores to have ever existed. Although an ideal prey for T. rex, Triceratops was by no means easily subdued. Fossils have revealed heel bite marks and wounds, showing that it had fought and survived life-or-death confrontations. Researchers still debate vigorously about the function of the horn frill. Was it for self-defense, attracting mates, or regulating temperature? Some modern hypotheses suggest the Triceratops frill also served as an attachment point for large neck muscles, giving it an extremely powerful thrust. At the Hell Creek Formation, where Triceratops was common, group fossils have been found, suggesting they lived in small herds rather than solitarily as many earlier documents assumed. In contrast to the heroic appearance of Triceratops, Ankylosaurus was a symbol of fortitude. With armor like iron plates, a flat head, and a distinctive tail club, this dinosaur was a nightmare for any predator daring enough to attack. Ankylosaurus fossils are found frequently in Canada and the northern United States, indicating they were adapted to cooler climates and lived near low-lying forests. A swing of their tail could break a predator's bones if it hit its mark, turning them into moving fortresses on the ancient plains. However, despite their strength or numbers, the giant herbivores could not have survived without a supportive ecosystem. Trees, flowering plants, and gymnosperms all created a biological energy bank that nourished the dinosaur herds. Along with that was the development of microorganisms in their digestive systems, helping them break down cellulose, similar to modern-day cattle. It was this cooperation between herbivorous dinosaurs and the plant kingdom that sustained life throughout the Cretaceous. And miraculously, not only bones, but also fossilized skin impressions, soft tissue, and even mineralized internal organs have been found in some hadrosaur individuals. These discoveries, such as those in North Dakota, help scientists reconstruct in detail their skin color, muscle structure, and living habits. For example, one individual showed signs of having drowned in a flash flood. Its body buried so quickly that the soft tissue retained its shape, revealing much valuable information that dry bones could not tell. In the world of dinosaurs, the herbivores were not always the weaker ones. On the contrary, they were the foundation of the ecosystem, the pioneers who forged paths through dense forests, the shields for their young, and a reflection of persistent life. Every horn, every scale, every footprint left behind is evidence of a life that was not just long, but profound. In the deeper strata of time, the herbivorous beasts existed not just as individual creatures, but as links in an extremely complex ecological chain. Their presence directly influenced how plant species were distributed, shaped the landscape, and even impacted the evolution of their predators. In the ancient, dense forests, every step of a hadrosaur herd could create trails, opening paths for smaller species, from reptiles to ancient insects, to coexist. The clearings they trampled, the leaves they ate, and even their dung, all were factors contributing to the life cycle. Another less-mentioned aspect is the environmental role of dinosaur dung. Like modern elephants, large herbivores excreted a significant amount of waste, which not only helped redistribute nutrients, but was also a source of life for a host of microorganisms, insects, and small plants. Many modern simulations show that fossilized dung piles, coprolites, are full of fiber, seeds, and even undigested bark, all evidence of the complex nutritional chain that existed at that time. Delving deeper into the interactions between species, scientists began to discover that the diversification of herbivorous dinosaurs led to a counterwave of evolution in predators. As herbivores defended themselves with armor, spikes, horns, or speed, carnivores had to develop stronger jaws and smarter hunting methods, a biological arms race that lasted for tens of millions of years. Among them, Triceratops and Ankylosaurus are prime examples. Each set of armor, each tail club swing, was not just a result of nature, but a product of evolutionary conflict. At T-fossil sites in Colorado and Utah, scientists have found traces of battles between herbivores and carnivores, broken teeth, rex teeth embedded in Triceratops bone, or fracture marks on Ankylosaurus armor that match the attack force of a contemporary predator. Such evidence proves that the herbivorous beasts were not just victims, but true warriors in the fierce struggle for survival in the Cretaceous. The special point to emphasize is the evolution of social behavior. Although fewer fossils clearly show social structures, as they do for carnivores, hadrosaurs, and maiasaura, left many signs suggesting coordination within the herd, with positions assigned by age or role, like a primitive society. This is reinforced by the discovery of concentrated nesting sites, trackways in formation, and fossils of many young of the same age at the same location. It seems that living in herds not only provided protection, but also promoted the transmission of survival skills between generations. Today, when we admire the reconstructed specimens in a museum, from the giant skeleton of a Triceratops to the model of an Ankylosaurus with its gleaming armor, we see not just an extinct creature, but an evolutionary story written in time and stone. They are symbols of the ability to survive in hardship, of stability amidst chaos, and of nature's relentless evolution. In many paleontological parks in the U.S., visitors can see meter-long fossilized hadrosaur footprints preserved in their original rock. Some might bend down, place a hand in the impression, and imagine a creature twice their height that once placed its foot right in that very spot. Moments like these are the bridge between the present and the past, reminding us that life, though it changes, is never truly lost. Finally, the giant herbivorous beasts have left a legacy in science and artistic inspiration. Hundreds of films, books, models, and research projects continuously recreate their image, not just because of their enormous size, but because of their resilient spirit, quiet yet powerful. They are not famous for their ferocity, but for their persistent ability to survive in a harsh world, leaving behind their mark as a glorious chapter in the great book of Earth. Looking back at the paleontological history of the United States, it is clear that the story of dinosaurs cannot be told completely without the herbivores. They were the foundation, the solid backdrop for the colorful painting of the Cretaceous period, where each herbivorous beast did not just eat, live, and die, but left an indelible mark on this very land. When it comes to dinosaurs, perhaps no name makes a stronger impression than Tyrannosaurus rex, the immortal king of the prehistoric world. With its colossal jaws, blade-like teeth that could crush bone, and a physique that was both terrifying and majestic, T. rex has long been a symbol of power, violence, and dominance in nature. But behind that image is a profound biological story, a chapter of evolution filled with incredible change, competition, and adaptation. Approximately 68 to 66 million years ago, in the land that is now the western United States from Montana to South Dakota, T. rex emerged as an evolutionary pinnacle of the Tyrannosaurid family. It was not always the greatest predator. Before it, the ancestors of T. rex were merely small, slender creatures that ran fast and primarily scavenged. However, over millions of years, fluctuations in climate, terrain, and the pressure of competition spurred a spectacular metamorphosis in their bodies and survival strategies. T. rex was not just large. It stood over 6 meters 20 feet tall, was nearly 12 meters 40 feet long, and weighed up to 8 tons, but it also had the most powerful bite ever recorded in the terrestrial animal kingdom. Its bite force is estimated at 6 to 8 tons of force per square centimeter, enough to crush the femur of an adult Triceratops. However, that power came not from jaw muscles alone, but from a unique skull structure. It was just elastic enough to absorb shock, yet rigid enough to transfer maximum force into every bite. Among the fossils found in the Hell Creek Formation, one of America's greatest paleontological treasures, the remains of T. rex are not just scattered bones. A nearly complete skeleton of a female specimen named Sue was excavated and is now displayed at the Field Museum in Chicago. From her, scientists have gained a more detailed view of the species' body proportions, mobility, soft tissue structure, and potential behaviors. No longer just a mindless killing machine, T. rex emerges as a complex creature capable of sensing, observing, and selecting its prey. That a major question in paleontology once sparked intense debate. Was T. rex an active predator or merely a scavenger? Modern research suggests the answer is likely both. Fossils show heel bite marks on Triceratops bones, meaning T. rex had attacked and the prey had survived, proving predatory behavior. However, its highly developed sense of smell and a skull optimized for breaking bones also support the hypothesis that T. rex frequently ate carrion, an intelligent survival strategy in a highly competitive environment. Compared to other carnivorous dinosaurs, T. rex possessed many distinct characteristics. In contrast to smaller, more compact predators like Deinonychus or Dromaeosaurus, which relied on agility, curved claws, and pack tactics, T. rex leaned toward absolute power. It was capable of taking down large prey on its own. However, this did not mean smaller species were weaker. Deinonychus, found frequently in Texas and Oklahoma, was famous for the sickle-shaped claw on its hind foot, capable of piercing through thick skin. Dromaeosaurus, a close relative of modern birds, had light but strong bones and a large eye structure, allowing for precise hunting at night. This group of smaller carnivorous dinosaurs, often called raptors, had high intelligence, the ability to coordinate in groups, and flexibility in hunting. While T. rex was a symbol of solitary power, the dromaeosaurs were the embodiment of tactics and agility. This suggests that the Cretaceous ecosystem was not just a place for giants, but also a fiercely competitive arena for different survival strategies. Despite its fame for its terrifying appearance and bone-crushing bite, the evolutionary success of T. rex did not come from physical strength alone. Recent studies reveal a much more complex picture, one in which intelligence, environmental awareness, and even the potential for socialization played no small part in its dominance. The skull of T. rex had a rather large brain cavity, especially in the regions for processing smell and sight, indicating it could locate, sense, and track moving prey in complex environments. Paleontologists believe T. Rex may have had stereoscopic vision, meaning its two eyes face forward, similar to modern cats or birds of prey. This would have provided a huge advantage when stalking and attacking prey in dense forests. Additionally, its ability to hear low-frequency sounds helped it detect movement from afar, an effective tool in the wild. However, the most interesting aspect lies in its potential for communication and social organization, which was previously overlooked. Some fossil evidence, such as trackways in groups and assemblages of multiple individuals in the same area, suggests that T. rex may not have been as solitary as once thought. Smaller individuals could have been offspring or juveniles moving in groups for protection or to learn hunting skills. This opens up an interesting hypothesis. Could it be that T. rex was not just a super predator but also a creature with certain social bonds? In the bigger picture, the predators of the Cretaceous in North America did not exist in isolation. They formed an intricate web of ecological relationships, where one predator could be the prey of another when young or in a disadvantageous situation. Smaller species like Dromaeosaurus may have lived in the shadows of the giants, attacking quickly and retreating before a counterattack. Meanwhile, species like Dakotaraptor, a newly discovered large raptor, may have competed directly with T. rex in some geographical areas, sharing prey and territory. The role of an evolutionary arms race cannot be ignored. Curved claws, razor-sharp teeth, and long tails for balance, all were the result of millions of years of relentless evolution to adapt and excel. But above all, perhaps the most formidable weapon was the flexibility to adapt to the environment. The predators of Cretaceous North America overcame climate change, competition, ecological crises, and even major storms to survive, leaving their mark in the fossil record as a testament to the power of nature. Interestingly, although T. rex is considered the most powerful predator, it was not the longest surviving species. Some species like Troodon, one of the most intelligent dinosaurs, existed from the mid-Cretaceous and maintained their presence longer due to their compactness, intelligence, and avoidance strategies. This shows that evolutionary success does not always mean being big and strong. Sometimes it lies in the ability to adapt in silence. Today, T. rex continues to live on in the imaginations of millions, not just through films like Jurassic Park, but also through models, textbooks, and even virtual reality games. It is an irreplaceable symbol of the majesty and mystery of prehistoric times. But what makes T. rex special is not just its size or bite force, but its ability to make people today still ask questions. How did they live? Did they think? Perhaps in every piece of fossilized bone, in every footprint still imprinted on ancient sandstone, there remains a whisper from a species that once ruled the earth. Closing the picture of these fierce predators from the King T-Rex to silent assassins like Dromaeosaurus, one cannot help but be amazed at the diversity, complexity, and sophistication of the ancient world. A world that was not just a battlefield of life-or-death struggles, but also a stage where nature displayed its ultimate creativity in designing life. In the hundreds of millions of years-long journey of life on Earth, perhaps no chapter is as miraculous and full of surprises as the transition from dinosaur to bird. They seem like two separate worlds. On one side, colossal creatures that dominated the land with overwhelming power. On the other, graceful, flying beings scattered across the sky. But in reality, they are connected by an unbroken evolutionary chain clearly marked right in the heartlands of America. Millions of years ago, the present-day plains of states like Kansas, Wyoming, and South Dakota were once shallow seabeds or humid rainforests, home to countless creatures. But more notably, it is in the sedimentary rock layers here that paleontologists have unearthed the fossils revealing one of the greatest events in biological history. The birth of birds from dinosaurs, the IT all began with small but powerful clues. Fossilized feathers, with a special structure resembling modern bird feathers, were found attached to the skeletons of small dinosaurs belonging to the theropod group, which were close relatives of Tyrannosaurus rex. Species like Microraptor, Archaeopteryx, though famous in Europe, and similar species in North America like Anchiornis became living bridges, clearly demonstrating the transition in morphology, structure, and function that end the limestone layers of Kansas, particularly in an area called the Smoky Hill Chalk. A strange fossil appeared. Hesperornis, a prehistoric bird that couldn't fly, but was an excellent swimmer, with sharp teeth, specialized leg bones, and clear traces of powerful lower limbs. It represents a time when birds were experimenting with various survival strategies, from soaring and running to diving underwater like today's penguins. Not far from where Hesperornis was found, fossils of Ichthyornis also emerged, a flying bird that still had teeth with an appearance similar to a modern seagull. It had long wings, developed feathers, and an expanded breastbone, a sign of quite effective flight capabilities. What is special is that Ichthyornis had a developed brain, indicating the growth of information processing abilities, navigation, and possibly sophisticated visual perception, traits that have become the essence of modern birds today. The presence of species like Hesperornis and Ichthyornis in the interior of America is extremely important because they prove that the evolution from dinosaur to bird was not a rare event that occurred only in an isolated geographical region, but a global phenomenon with a strong center of development in North America. However, it's not just complete fossils that tell the evolutionary story. Paleontologists have also discovered microscopic traces on fossilized bones, showing changes in bone marrow structure, a decisive factor in creating the light, hollow bones characteristic of flying birds. Additionally, fossilized eggs, nests, and footprints also provide clues about nesting and parental care behaviors, things previously thought to exist only in birds, but now seen in many feathered dinosaurs. Discoveries in Wyoming, especially in the late Cretaceous rock layers, also brought many surprises. Some unnamed bird fossils, with small ribs, flexible vertebrae, and especially slightly curved toe bones, show the ability to perch on branches and use their forelimbs like modern birds. They were not just drafts of swans or hawks, but a clear manifestation of a great transformation in the history of life. But it must be emphasized that this transition was not linear. Not all feathered dinosaurs evolved into birds. Many species only experimented with bird-like structures such as having feathers, long forelimbs, and light bones, but ultimately still went extinct. Only one small branch, the aviali, truly evolved into the birds we see today. Right here in America, this branch has left unmistakable marks, not only through fossils but also through genetic evidence. Studies of ancient DNA, comparing the gene sequences of modern birds with data extracted from fossilized bones, combined with isotope analysis and CT scans, show clear similarities in the developmental sequences of feathers, beak shapes, and skeletal structures, all creating a continuous and powerful evolutionary story. At the end of the Cretaceous period, about 66 million years ago, life on Earth was shaken by a terrifying geological event, the Chicxulub asteroid impact on the Yucatan Peninsula, an event that permanently changed the face of the planet. The consequence was the disappearance of 75% of all living species, including all non-avian dinosaurs. In that destruction, a few species survived, and among them were the first representatives of modern birds. The question that has troubled scientists for decades is, why did birds, the direct descendants of dinosaurs, survive while close relatives like T. rex were wiped out? The answer may lie in their small size, flexible diet, ability to fly, and ground nesting habits, all of which helped birds adapt more quickly to the harsh conditions after the catastrophe that in North America, especially in the Hell Creek Formation, Montana, North Dakota. Post-impact bird fossils have been found in sedimentary layers just above the KPG geological boundary, proof of the survival of some prehistoric bird species immediately after the impact. While the environment was devastated, the climate changed abruptly and sunlight was blocked by dust clouds for years. Birds seemed to have hunkered down, seeking smaller ecological niches, where there was enough food, light, and conditions to sustain their survival. From those ruins, an explosive diversification took place over the next few million years, similar to the rapid development of mammals. Birds gradually took over the environments left vacant by dinosaurs, from dense forests and coastlines to arid plains. This process is called adaptive radiation. a phenomenon in evolution where an ancestral species diversifies and adapts to create many different descendant branches. In the American fossil record, scientists have found evidence of many modern bird families, paleognaths, ancestors of ostriches, rheas, and cassowaries. Their fossils are often found in the western plains. Neognaths, the main group of modern birds, including sparrows, ducks, and chickens, which appear commonly in the Paleocene rock layers of Colorado and Wyoming. Fossilized footprints and bird nest structures show the expansion of more complex nesting behaviors, strategic site selection, and even clear signs of flocking behavior, biological factors that helped increase survival rates across generations. More than just surviving, birds in America became one of the most brilliantly developing groups of organisms after the mass extinction. Predatory birds, fruit-eating birds, wading birds, seabirds appeared one after another, occupying different ecological niches. This reflects the continuous evolution of the brain, vision, and respiratory system, turning birds into perfect living flying machines, optimizing every gram of their body to deal with gravity and the demands of survival. Today, when we look up at the skies of America, from a flock of geese flying over the fields of Minnesota to a bald eagle spreading its wings over the Rocky Mountains, or a hummingbird flitting around wildflowers in Texas, we are witnessing the living legacy of the age of dinosaurs. These are the creatures that survived an apocalyptic impact, adapted, and then evolved into one of the richest and most complex animal groups on the planet. The story of birds in America is not just the next chapter after the dinosaurs. It is a magnificent testament to the power of evolution, where from the ashes of extinction, life still sprouted, took flight, and sang across the world. If dinosaurs were the masters of the land for hundreds of millions of years, then in the skies and beneath the oceans other creatures, no less magnificent, also reigned. Within the geographical framework of Cretaceous America, flying reptiles and giant marine reptiles were not only special biological phenomena, but also left distinct fossil imprints, marking an era of unprecedented ecological diversity. First, let's look up to the ancient sky. One of the most prominent species found in the central United States is Pteranodon, a creature with a wingspan of up to 7 meters, 23 feet, often discovered in the limestone layers of the Niobrara Formation in Kansas. Interestingly, Pteranodon was not a dinosaur in the classic sense, but a pterosaur, a group of flying reptiles that lived at the same time as dinosaurs. However, because they shared the same habitat and period of development, they are an indispensable part of the prehistoric ecosystem. Pteranodon had a long skull with a toothless beak and a large bony crest at the back of its head that helped with balance and steering in flight. Contrary to the heavy image of dinosaurs, Pteranodon had a hollow and lightweight bone structure similar to modern birds. They are believed to have glided on sea winds, riding along air currents, rising from the water surface to search for fish and squid, the main food sources in their diet. What makes this species so magnificent is its habitat. The interior of the United States during the Cretaceous period was not dry land as it is today. A giant inland sea called the Western Interior Seaway split America into two halves, Laramidia to the west and Appalachia to the east. This sea stretched from the Gulf of Mexico to the Arctic, was teeming with marine life, and provided an ideal environment for pterosaurs to live, reproduce, and hunt. Here, millions of years ago, flocks of Pteranodon may have flown in clusters, similar to how seabirds gather seasonally today. Fossils in Kansas have also revealed sexual dimorphism in Pteranodon. Males had significantly larger crests, possibly to attract mates or display status within the group. This suggests they may have had more complex social behaviors than imagined, an interesting parallel to modern birds. Not only Pteranodon, but other smaller pterosaur species like Nyctosaurus have also been found in the limestone quarries of Kansas. This species had a bizarrely tall head crest, like a Y-shaped antenna, leading many researchers to believe it was a feature for display or navigation. Though not as famous as T-Rex or Triceratops, pterosaurs were still main characters in the ancient skies, helping to create a three-dimensional ecosystem in the air, under the water, and on the ground. The discovery of pterosaur fossils in the center of America, a region that is now entirely landlocked, is a vivid testament to the geological and ecological transformations that occurred over tens of millions of years. The layers of limestone and marine sediment are filled with fragile bone fossils, footprints, and even fossilized droppings, coprolites, of the creatures that once ruled the sky, helping to reconstruct the life of flight and predation over the ancient inland sea. However, the sky was not the only realm filled with incredible creatures. Beneath the surface of the western interior seaway lay another world, a world inhabited by giant hunting machines, Mosasaurus and Elasmosaurus, the true masters of North America's prehistoric ocean, that if the ancient sky belonged to Pteranodon, then the giant inland ocean of the Cretaceous was the domain of magnificent marine creatures, most notably Mosasaurus and Elasmosaurus. These two species were not only icons of the late Cretaceous, but also vivid proof of the evolutionary capabilities of reptiles in the deep-sea environment. Mosasaurus, often dubbed the sea dragon, though not actually a dinosaur, was one of the largest aquatic predators to have ever existed. With a length that could reach up to 15 meters 50 feet, razor-sharp teeth, and an extremely powerful bite, Mosasaurus was the nightmare of every creature living in the western interior seaway. Traces of their fossils are found widely in states like Kansas, South Dakota, and Nebraska, places that were once the seabed. Mosasaurus had a long, slender body like a snake, a flattened tail like a fish fin, and fore and hind limbs that had evolved into powerful paddles. They could dart through the water to chase prey, mainly large fish, ammonites, prehistoric squid, sea turtles, and even other marine reptiles. A special feature was the Mosasaurus's skull, which could expand similarly to modern snakes, allowing it to swallow prey larger than its own head. In contrast to Mosasaurus was Elasmosaurus, the longest-necked marine reptile known. Reaching up to 14 meters 46 feet in length, with nearly 7 meters 23 feet of that being its neck, Elasmosaurus had such a strange shape that when it was first discovered, scientists mistakenly attached its head to the wrong end, the tail. Its long neck, with dozens of vertebrae, allowed it to flexibly extend its head through the still water, silently approaching small prey, without moving its entire massive body. Elasmosaurus belonged to the Plesiosauria group, another branch of marine reptiles that were not dinosaurs but lived at the same time and shared the ocean with them. With 4 fin-like limbs for rhythmic movement, good eyesight, and the ability to maintain balance in the water, Elasmosaurus is a prime example of the incredible adaptation of reptiles to the deep-sea environment. One of the interesting points is that both Mosasaurus and Elasmosaurus lived in the western interior seaway, where today there are endless cornfields in Kansas or limestone plateaus in South Dakota. Finding their fossils at different sedimentary depths shows that they occupied various marine ecological tiers, from shallow coastal waters to the deeper central areas of the ocean. The fossil record reveals fragmented skulls, broken teeth, vertebrae, and even stomach stones, gastroliths, or fossilized droppings of these creatures. All of this helps paleontologists reconstruct not only their appearance, but also their hunting behaviors, ecological interactions, and even the struggle for survival among the top predators of the era. The combination of flying reptiles like Pteranodon and underwater beasts like Mosasaurus and Elasmosaurus shows that the western interior seaway was not just a shallow sea, it was a vast and complex ecosystem where three-dimensional space was filled with sophisticated predators possessing incredible body structures and survival strategies. Today, when we see their fossils displayed in museums in Chicago, Denver, or Washington, D.C., we are not just looking at petrified bones, but at the living story of an ancient era where the skies and seas of America were once the stage for unimaginable creatures. From the powerful wings of Pteranodon, the deadly bite of Mosasaurus, to the bizarre neck of Elasmosaurus. All are testaments to the richness and wonder of evolution during the age of dinosaurs. In the places that are now the vast plains, sheer cliffs, and arid lands of North America, there once existed dense forests, meandering rivers, and herds of dinosaurs striding through damp mud. Here, the past still lingers, not through spoken words, but through petrified bone fragments, deeply imprinted footprints, and storytelling sedimentary layers. These fossil holy lands of America are not just destinations for researchers, but also living proof of a golden age of life on Earth. Among them, the most prominent is the Hell Creek Formation, an area stretching across the states of Montana, North Dakota, South Dakota, and Wyoming. This is one of the richest fossil-bearing sedimentary formations in the world, recording the final moments of the Cretaceous period and the milestone marking the beginning of the Paleogene period. The name Hell Creek sounds like an omen, and indeed, it is a place that contains both life and death, both the glory of the dinosaurs and the moment of their extinction. Hell Creek is famous not only for its enormous quantity of fossils, but also for many revolutionary discoveries in the history of paleontology. Here, scientists have found nearly complete specimens of Tyrannosaurus rex, Triceratops, Edmontosaurus, and many other dinosaurs that lived at the end of the Cretaceous. Not just bones, the fossils also include bite marks, traces of predation, coprolites, fossilized dung, and rare fossilized skin and soft tissue, providing a panoramic view of the daily lives of dinosaurs. During an excavation in 1902, the legendary paleontologist Barnum Brown, then a young researcher for the American Museum of Natural History, discovered the first bones of Tyrannosaurus rex in Montana. This specimen sent shockwaves through the scientific community, opening a new era in the study of carnivorous dinosaurs. Since then, Hell Creek has become a hotspot for excavations, a place where international research teams, archaeology students, and even paleontology-loving volunteers flock to each year. Another unique feature is that at Hell Creek, chemical traces of the Chicxulub asteroid impact have been found with high concentrations of iridium, a rare element often associated with extraterrestrial objects. This thin layer of iridium-rich soil marks the K-PG boundary, separating the age of dinosaurs from the age of mammals. It is like a natural dividing line, splitting two eras of life on Earth. Not limited to dinosaurs, Hell Creek also records fossils of plants, fish, turtles, crocodiles, early mammals, and even fossilized insects. Fossilized plant specimens like palm fronds, ferns, and seeds have helped reconstruct the ancient climate and ecological picture vividly. Thanks to this, scientists not only know who lived there, but also how they lived, how they interacted, and how they met their endpoint. One of the most sensational recent discoveries is the dueling dinosaurs fossil two individuals believed to have been fighting. A T-Rex and a Triceratops fossilized together in a confrontational pose. Although there is still much debate about the formation process of this fossil, it is living proof of the real interaction between large dinosaur species, not just in theory, but right in the rock strata. Hell Creek is not merely a geological landmark. It is a doorway to the past, a vast natural museum where every stone, every bone fragment carries a story millions of years old. With this special role, Hell Creek has become an indispensable symbol in the journey of dinosaur discovery, laying the foundation for modern understanding of the evolution, extinction, and recovery of life on this planet that, if Hell Creek is the shining jewel in America's fossil crown, then the Two Medicine Formation, stretching across Montana, is a gem of a unique color, revealing lesser-known aspects of dinosaur life in North America. With geology dating from the mid to late Cretaceous, Two Medicine is famous not only for fossils of the species Maiasaura, the good mother lizard, but also for the fossilized nests that prove parental care behavior in dinosaurs, something that was previously doubted. It was here that paleontologist Jack Horner, one of the biggest names in the field, discovered nests arranged in an orderly fashion, with developing embryos inside and scratch marks indicating the young had once moved. These nests were found along with fossils of adult dinosaurs, leading to the hypothesis that some dinosaur species lived in herds and cared for their young in nests, rather than abandoning them after laying eggs like most modern reptiles. This discovery completely changed how we view the intelligence, social behavior, and evolutionary capabilities of dinosaurs. Two Medicine also provides fossils of many other species, such as Daspletosaurus, a close relative of T-Rex, Hypacrosaurus, and various species of crested, duck-billed dinosaurs that lived in large herds. What is special is that the stratigraphy here reveals layers of volcanic ash, which covered the area during violent eruptions millions of years ago. The volcanic ash not only helped preserve the fossils, but also aided in accurately dating the rock layers and the specimens within them. Moving south, we come to another paleontological treasure, Fossil Butte National Monument, located in Wyoming. While not a site for large dinosaur discoveries, Fossil Butte is a paradise of fish and freshwater creature fossils dating back over 50 million years to the Eocene epoch. Here, fossils of fish, turtles, rays, crocodiles, bats, and even plants are preserved almost perfectly with details of scale, fins, and even ice structures intact, thanks to the extremely anoxic and stable limestone sediment environment. Fossil Butte was once the bottom of a large ancient lake called Fossil Lake, where the calm, oxygen-poor water created ideal conditions for organisms after death, not to decompose, but to gradually fossilize over time. This helps scientists study in detail the anatomy, diet, ecosystem, and ancient environmental changes. Many fossils here are so beautiful, they are likened to works of art of time and have become premier exhibits in museums across the U.S. Fossil Butte does not tell stories of giant dinosaurs or dramatic survival battles, but rather offers a delicate narrative of a post-dinosaur freshwater ecosystem, a period when mammals began to diversify and step into their dominant role. Therefore, though not as glamorous as Hell Creek, this place still plays an essential role in piecing together the evolutionary history of life. Landmarks like Hell Creek, Two Medicine, and Fossil Butte are not just points on a map, they are living chapters in the history book of Earth, where each layer of rock, each fragment of bone, is a petrified memory preserved over tens of millions of years. They allow us to see the past not only with scientific reason, but also with admiration and awe for the diversity and extraordinariness of life. IT is thanks to the fossils from these legendary lands that humanity can imagine, reconstruct, and retell the magnificent story of dinosaurs, not just as giant, extinct creatures, but as the main actors of a biological universe that once existed right beneath our feet. The sun gradually rises above the horizon of a land that was once the American West, approximately 68 million years ago. Sunlight pierces the thin mist over fields of ferns and coniferous forests, creating a hazy picture of a distant world, a place where no human footprint has ever been left. This is a time when dinosaurs still ruled the earth, and a herd of hadrosaurs, duck-billed dinosaurs, is beginning its new day on the ancient plains of the region, now known as the state of Montana. The first sound is not the singing of birds, but the chirping of prehistoric insects, the low calls of adult hadrosaurs summoning their young to stay close. These giant dinosaurs could reach up to 10 meters 33 feet, long and weigh several tons, yet they moved with a graceful fluidity among the low-lying trees. They were herbivores, primarily living in herds, a social structure formed to protect the young from lurking predators. While some individuals stand guard, others leisurely pluck leaves from dense bushes, using their duck-like beaks to cut roots, young leaves, and soft branches. With hundreds of teeth packed closely together in their large skulls, hadrosaurs could efficiently grind tough vegetation, digesting the enormous amount of food needed to maintain their energy. Not far away, a lone T. Rex moves silently through a patch of forest. Despite its immense size and formidable reputation, the T-Rex was not always the dominant force. It required tactics, patience, and opportunity. The old, weak, or young individuals in the hadrosaur herd were its ideal targets. Each step of the multi-ton predator caused the ground to tremble slightly, but the survival instincts of the hadrosaur herd had been honed over millions of years. An adult raises its head high and lets out a long call, the sound echoing through the trees, an alarm call. In just a few seconds, the entire herd moves into a tight group, the young surrounded in the middle, with the large individuals on the outside ready to fight back if necessary. The T-Rex knows the element of surprise is lost. It does not waste energy on a futile chase. It turns its head and retreats into the shadow of the forest, awaiting another chance. The hadrosaurs continue their journey, this time changing direction, heading toward an ancient river trickling through the low-lying plain. That river. Ancient life is on full display. Bony fish swim in schools, water turtles sunbathe on logs, and the Dinosaur, a giant prehistoric crocodile, lies silently beneath the murky water, only its eyes visible as it tracks the movement of the dinosaur herd. The hadrosaurs approach the riverbank, cautiously. They are well aware of the danger that comes from beneath the water surface, not only from Dinosaurs, but also from strong currents that could sweep away the young. However, water is essential not just for drinking, but also for cooling their bodies in the hot and humid tropical climate. Groups take turns drinking while others remain on guard. Evening gradually descends upon the ancient prairie. The last rays of the day stain the thin mist covering the giant fern canopies yellow, creating a brilliant sunset scene in the prehistoric world. The hadrosaur herd continues its journey toward higher ground, avoiding the low-lying areas prone to flooding at night. The atmosphere softens, and the rhythm of the ancient forest begins to shift into its twilight state. Insects emit a repetitive sound like a prehistoric symphony. In the gentle breeze, the scents of plants, pollen, and damp earth blend together, a characteristic smell of an ecosystem that modern humans have never experienced. That a group of hadrosaurs stops by a clearing, a place that was once a dried-up marsh, to rest for the night. The adults begin to form a protective circle, with the young brought into the center. It is no coincidence that this species developed strong social habits. It was through this unity that they could survive for tens of millions of years. Meanwhile, deep in the forest, a pair of troodontids, small, highly intelligent carnivorous dinosaurs, move silently through the undergrowth. Only the size of a turkey, but with an unusually developed brain for their body ratio, troodontids did not hunt large prey. Instead, they search for eggs, carcasses, or stray young. As night falls, their vision and hearing become an advantage, and they, with their large eyes and excellent positioning abilities, quietly creep near the area where the hadrosaur herd is camped. But they are not alone. An Acaroraptor, a small dromaeosaurid, a close relative of the velociraptor, is hiding behind rotten logs. It, too, is lurking for an opportunity not to attack, but to claim a share in any successful hunt. In this ancient world, survival was not for the weak and not for the solitary. From a distance, the sound of thunder echoes. In the western sky, dark clouds begin to swirl, signaling an approaching tropical storm, a common occurrence in the late afternoon in the hot, humid climate of the Cretaceous. The hadrosaurs lift their heads to the sky. Many individuals begin to push together, seeking higher ground. Ancient instincts tell them that the rain can be accompanied by lightning, strong winds, and floods. Dangers no less threatening than predators. As the first drops of rain fall, the entire forest awakens. Leaves rustle, the ground steams, and the smell of fresh mud spreads through the air. The hadrosaur herd huddles under the dense canopy, shielding one another. Some individuals shiver from the cold, especially the young, but the tight protective circle of the herd helps retain heat like a biological suit of armor. Meanwhile, the troodontids have gotten close to the edge of the herd. A stray individual, young and weak, has fallen behind. It lets out a soft cry, its small legs stumbling on the slippery ground. This is the chance. A shadow shoots forward. But it's not the troodontids, it's the Acaroraptor. It attacks first, seizing the target. However, the piercing cry has alerted the herd. An adult whips around, using its tail to strike powerfully at the bushes, driving away the intruder. The Acaroraptor vanishes like the wind. The troodontids also retreat. The young one is pulled back into the middle of the herd, where it is safer. The rain is now heavy, but the rhythm of life continues. Every second is a test of survival. Every action is the result of millions of years of evolution. Near midnight, the rain stops. The moon emerges from behind the clouds, shining down on the wet earth and the silently sleeping figures of the dinosaurs. Some adults remain awake, their eyes watchful. In that dim darkness, the prehistoric ecosystem seems frozen in time, a place where these creatures had no idea that one day the descendants of another species would come, excavate their bones, and tell this story, the story of life, struggle, adaptation, and disappearance, recorded in fossils and echoing through time. The sky above gradually turns a clear blue as the mist dissipates, revealing the rich life in the air. Pteranodons soar on outstretched wings, searching for fish near the waters. Surface, occasionally gliding over the heads of the hadrosaur herd. They pose no threat, but are part of the vast ecosystem. where every species has a specific role in the ancient web of life. Every movement, every sound in this environment carries meaning. It is symbiosis, competition, defense, and adaptation. As the sun climbs higher, the hadrosaur herd retreats into a densely wooded area to escape the midday heat. Some lie down to rest, while others search for succulent plants in the shade of the trees, a behavior that shows their ability to recognize microecosystems. Time passes quietly. In a world with no machines, no human voices, every rhythm of life is regulated by light, rain, and the calls from deep within the forest. It was a closed but vibrant universe, where the hadrosaur was not just an herbivore, but a core part of a prehistoric ecosystem operating hour by hour, minute by minute. A peaceful morning begins on the vast plains of western North America, an area now known as the state of Montana. Near the end of the Cretaceous period, the sun has just risen above the horizon, its golden light shining through thin clouds, illuminating a prairie teeming with life. Herds of hadrosaurs leisurely graze on leaves by the riverbank, a triceratops leads its young on a slow walk through fields of ferns, and in the distance, a pair of Tyrannosaurus rex follows the fresh blood trail of a wounded Anatosaurus. The scene is one that has been familiar for millions of years. None of these magnificent creatures knows that, in just a few hours, an event will occur that will end their era forever. Far to the south, thousands of miles away, a streak of light appears in the sky above the Yucatan Peninsula, now part of Mexico. At first, it looks like a small shooting star, but it quickly grows larger, more brilliant, and carries an unprecedented, piercing screech. This is no ordinary meteor. It is an asteroid more than 10 kilometers 6 miles in diameter, traveling at over 70,000 kilometers per hour, 43,500 miles per hour, carrying the energy equivalent of billions of atomic bombs. The moment it struck the Earth, everything changed. The impact created the Chicxulub crater, over 180 kilometers, 110 miles, wide and tens of kilometers deep. The force of the collision immediately incinerated all life within a radius of thousands of kilometers. The surface temperature rose beyond the boiling point of metal, and rock was blasted into the atmosphere, creating a reverse meteor shower that rained back down across the globe. Back in North America, minutes after the impact, the sky lit up as bright as day. Dinosaurs thousands of kilometers away, in places like Texas, Utah, and the Dakotas, began to panic. The ground shook with the force of a magnitude 10 earthquake, volcanoes awakened in droves, and tsunamis hundreds of meters high slammed into the mainland that a triceratops drinking water at Fossil Lake jerks its head up. The lake's surface trembles as if a giant creature is moving beneath it. Ancient birds fly in disarray. Pterosaurs scream from above. In the forests, herbivores move in a panic, not understanding what is happening. After the first few hours of the impact, the sky over North America turns a grim gray, covered in rock dust, sulfur, and smog. The sunlight is blocked, and temperatures begin to plummet rapidly. A nuclear winter has begun, one that will last for months, perhaps even years. Plants can no longer photosynthesize, trees slowly die off, leading to a chain collapse of the entire food chain. Herbivores like hadrosaurs, ankylosaurs, and triceratops, which needed hundreds of kilograms of vegetation each day, begin to die of starvation. Carnivorous dinosaurs no longer have prey to hunt. Carcasses litter the landscape, and only a few small, scattered species that could hide and regulate their body temperature manage to survive for a few more months. Acid rain begins to fall from the sulfurous clouds, burning skin and making the water in rivers and lakes toxic. Insects disappear. Undergrowth plants die in mass, and the dust in the atmosphere continues to keep the Earth in a frigid state. Ecosystem after ecosystem, from North to South America, collapses. In places that were once bustling, like Hell Creek or Two Medicine, now there are only wastelands covered in ash and the fossilized remains of the creatures that once ruled the planet. In that bleak landscape, smaller groups of animals, like early mammals and primitive birds, slowly begin to emerge. They didn't need much food, could burrow to escape the cold, and lived on the remnants of the old ecosystem. This was the beginning of the end of the age of dinosaurs and the irreversible transition to a new era for the Earth. as radioactive dust, volcanic ash, and toxic gases from the Chicxulub impact continued to envelop the atmosphere. The Earth entered a period of profound crisis. Global temperatures dropped sharply and tropical regions, which were the primary habitats of the dinosaurs, became cold and dark. Each passing day, the sun shone for only a few minutes, and vegetation withered away like a candle extinguished in the wind that on the plains of Hell Creek. Once home to the richest ecosystem of the Cretaceous, the massive carcasses of dinosaurs slowly turned into white bones under a layer of ash. A triceratops died beside its young. The Tyrannosaurus, despite being the apex predator, could not survive when there was no more prey to hunt. The few rare survivors had to burrow deep into caves, under rotting forest canopies, or near warm springs that retained heat from the Earth's core. Some geothermal lakes, like those in the area now known as Yellowstone, became the last refuges for prehistoric birds and early mammals. Birds, as the direct descendants of theropod dinosaurs, had feathers for insulation and the ability to fly far, becoming one of the few creatures to remain. Small mammals, like the multituberculates, began to proliferate rapidly, taking over the remaining ecological niches. They ate animal carcasses, leftover seeds, or insects that survived in the soil. More importantly, they could reproduce quickly, live in low-light environments, and regulate their body temperature, a crucial advantage for survival in the Dark Age. Approximately 75% of all species on Earth disappeared. Not just the dinosaurs, but also the giant marine reptiles like mosasaurs, the flying pterosaurs, and the ammonites, one of the most common mollusks in the ocean, also went extinct. The Western Interior Seaway, which had once split America in two during the age of dinosaurs, now began to recede. The global drop in sea level after the impact caused this inland ocean to disappear, leaving behind a layer of fossil-rich sediment stretching from Texas to North Dakota. The end did not come in a single night, but was a process that lasted for months, even several years. But the result was irreversible. When the dust in the atmosphere finally settled and the sun shone once more, the Earth had changed forever. There were no more giant dinosaurs striding across the plains, no more roars echoing from the primeval tropical forests. Instead, there was a new world, desolate, harsh, but also the crucible for the rise of the mammals that would evolve into elephants, horses, whales, and eventually humans. The Chicxulub impact was not just the end of an era, but also a great question mark for the biological future of the planet. It reminds us that even the most powerful creatures are not invincible against nature, and that the end of one species can be the beginning for another. And so, the age of dinosaurs ended, not with a battle, but with a reign of ash bleak, fierce, and eternal in the memory of the Earth. When the dust from the Chicxulub impact settled and the age of dinosaurs came to an end, a small but miraculous group of creatures survived and opened an entirely new chapter in the history of life: birds. Today, when you look up at the sky, the cheerful song or the beating wings of a sparrow, a hawk, or even a pigeon, all are lingering whispers from a distant, ancient past. They are the living legacy of the dinosaurs. Biologically, scientists have confirmed that modern birds belong to the theropod branch, the group of bipedal dinosaurs that includes illustrious names like Tyrannosaurus rex and Velociraptor. The evidence comes not only from bone fossils, but also from sophisticated details like the skull, the structure of fossilized feathers, the breastbone, and nest organization. Discoveries in the U.S., especially in areas like Montana, Wyoming, and Kansas, have provided thousands of precious specimens, allowing the scientific community to reconstruct the evolutionary process from dinosaur to bird over tens of millions of years. In the Fossil Butte area of Wyoming, a series of Paleocene-era bird fossils have been discovered with an extremely detailed level of preservation, down to the structure of feathers and beak shapes. Some species, like Ichthyornis, have a half-bird, half-dinosaur form. They had teeth like a reptile, but possessed wings, a large breastbone, and hollow leg bones like modern birds. These findings show that the transformation did not happen suddenly, but was a long process with many sophisticated intermediate steps. Today, the United States is home to one of the most diverse bird populations in the world, from quails and owls to eagles and tiny hummingbirds. That diversity is not just the result of natural evolution after the extinction event, but also living proof that dinosaurs never truly disappeared. They simply changed their shape, size, and lifestyle to adapt to a new world. Interestingly, the behavior of modern birds, from nest building, caring for young, and preening for hygiene to complex mating dances, all have ancestral traces from the age of dinosaurs. A fossil of an oviraptor was once discovered brooding on its eggs, and traces of this egg-carrying behavior have been perfectly preserved in rock for tens of millions of years. At universities and research institutes across the U.S., many educational and wild bird conservation programs are organized to help the public better understand the continuity between dinosaurs and birds. When a child places a hand on a dinosaur model at the Smithsonian or watches a bald eagle soar over Yellowstone National Park, few realize they are touching an unbroken chain in the history of evolution. Birds, through their songs, their wings, and their very existence, are proof that although the age of dinosaurs has passed, what they left behind still echoes in every biological heartbeat of this planet, that if birds are the living legacy, then fossils are the petrified pages of history, recording every detail of the dinosaur era. In the United States, the preservation and excavation of fossils are not just the work of the scientific community, they are also a part of popular culture, education, and experiential tourism. One of the most outstanding sites is Dinosaur National Monument, located on the border between Utah and Colorado. This was once part of the Morrison Formation, famous for the huge number of dinosaur fossils found, such as Allosaurus diplodocus and Stegosaurus. In the open quarry areas, visitors can directly observe fossilized bones still embedded in the rock, a rare experience that connects the present with the distant past. In Montana, the Hell Creek Formation is not just an archaeological site, it is also where paleontologists found the first complete T-Rex fossil. Every summer, groups of students, scientists, and even volunteers from all over flock here, turning over layer after layer of earth and rock in the hope of finding a bone, a tooth, or a footprint millions of years old. This site witnessed the discovery of Sue, the famous Tyrannosaurus rex skeleton, currently on display at the Field Museum in Chicago. Not just in nature, museums across the United States are also treasure troves preserving the dinosaur legacy. The Smithsonian Institution in Washington, D.C., the American Museum of Natural History in New York, and the Museum of the Rockies in Montana all possess some of the world's largest fossil collections. The giant skeletons assembled and standing tall in the exhibition halls not only amaze viewers, but also ignite a passion for science in millions of students. Besides bones, America is also famous for its fossilized footprints, known as ichnofossils. At Glen Rose, Texas, hundreds of dinosaur footprints are preserved in the limestone along the Paluxy River. Scientists have discovered tracks that show herding behavior, chases, and even parental care. This is invaluable evidence that dinosaurs were not just powerful creatures, but also had complex social behaviors. Experiential education programs such as Dig for a Day, which allows students to participate directly in excavation work, have turned learning about the history of life into a vivid experience. In South Dakota, some private paleontological ranches even offer tours for tourists to discover fossils on their land. From a conservation perspective, the government and nonprofit organizations have worked hard to protect valuable fossil areas with strict laws. Illegal excavation or trafficking of fossils is severely punished. At the same time, a series of national parks and geological reserves have been established to preserve the sedimentary layers that hold the past. Entering the 21st century with digital technology, 3D models, virtual reality VR, and interactive learning apps about dinosaurs are increasingly developing. Children can sit at home and still experience walking with dinosaurs thanks to AI and simulation technology, bringing the fossil legacy from the rock strata to the screen. The dinosaur legacy in America, whether fossilized or living, is not just a scientific story, but also a cultural symbol. It reminds us that beneath every layer of rock, there may still be a piece of history waiting to be told. And every step we take today, whether on a city avenue or in the wilderness, is on a planet that was once the domain of the most magnificent creatures to have ever existed. When one thinks of dinosaurs, many will immediately imagine the wildlands of Africa, the forests of South America, or the Gobi Desert of Asia. But in reality, no place on Earth preserves more dinosaur fossils or plays a more central role in the field of paleontology than the United States. From the red rock ranges of Utah to the vast plains of Montana, the United States is not only the homeland of a host of important dinosaur discoveries, but also the birthplace of a complete science of prehistoric life. The history of paleontology in America began to explode in the late 19th century during a period known as the Bone Wars. Two famous paleontologists, Edward Drinker Cope and Othniel Charles Marsh, competed fiercely to discover and publish new fossils. They organized expeditions throughout the American West, digging tirelessly from Wyoming and Colorado to Nebraska, to claim the honor of discovering new species. The result of this scientific war was a colossal legacy. More than 130 new dinosaur species were described, including names that would become icons like Triceratops, Stegosaurus, and Apatosaurus. Although their methods were somewhat extreme, it was this very competition that laid the foundation for modern paleontology in America Point. One of the reasons America became a holy land for dinosaurs lies in its special geological structure. Vast sedimentary rock formations like the Morrison Formation, Hell Creek, and Judith River contain dense fossil layers, thanks to ideal conditions for preserving the remains of ancient creatures, swamps, floods, ancient rivers, and coastal plains. The richness of its topography, climate, and geology throughout different periods makes the United States a living map of evolution. Not limited to quantity, the U.S. also boasts many iconic discoveries that have changed the way we understand dinosaurs. For example, the discovery of fossilized dinosaur nests in Montana reinforced the theory that dinosaurs exhibited parental care. And the Sioux skeleton, one of the most complete T-Rex specimens, has provided invaluable data on the anatomy, pathology, and hunting behavior of the species. Furthermore, the U.S. has also led the way in bringing dinosaurs into popular culture. From films like Jurassic Park to famous documentary series by National Geographic, the image of the dinosaur is not just confined to laboratories, but is deeply imprinted in the minds of millions through books, movies, and educational products. This creates a positive feedback loop where culture nurtures a passion for science and science provides a foundation for imagination to soar, from enormous museums to modern research centers, from fourth graders digging for fossils to PhDs reconstructing 3D models of extinct species. Dinosaurs in America are not just the past, but a vibrant part of the present. Tens of thousands of students enroll in paleontology programs, hundreds of research papers are published each year, and millions of tourists flock to fossil sites, all coming together to form an intellectual, cultural, economic ecosystem revolving around a creature that disappeared over 66 million years ago. America, in its role as a major center for dinosaur science, is marked not only by groundbreaking discoveries, but also by a spirit of preservation, learning, and inspiration. A land that not only once had dinosaurs, but is keeping them alive in museums, in the imagination, and in the hearts of science lovers around the world. Entering the digital age, the United States continues to demonstrate its leading role in applying technology to the research and dissemination of knowledge about dinosaurs. Centers like DG Morph at the University of Texas or high-tech laboratories at the Smithsonian and prestigious universities like Harvard, Yale, and Stanford have taken the image of the dinosaur to a new level through 3D models, 3D printing of fossil bones, and simulating dinosaur movement and behavior with AI. A prime example is the reconstruction of T-Rex movement using a biomechanical simulation system, giving scientists and the public a vivid look at its speed, hunting posture, and survival capabilities. Researchers no longer need to dig directly to see prehistoric life. A CT scan of a specimen is enough to reconstruct and analyze its bone structure with accuracy down to the micrometer. In parallel, paleontology education in the U.S. has also seen a powerful transformation. Institutions like the Paleontology Research Institution or the Denver Museum of Nature and Science not only organize traditional learning programs, but also create online courses, VR learning apps, and real-time interactions with scientists via live stream platforms. Paleontology summer camps for high school students are held annually where they can become real researchers for a time. America is also the cradle of many initiatives connecting the public with dinosaur science. One of the standout events is Dino Fest, held in various states like Utah, California, and Illinois, gathering thousands of paleontology lovers to listen to lectures, observe real fossils, participate in augmented reality games, and even get hands-on experience reconstructing a dinosaur skull from a model. Furthermore, efforts to preserve fossil knowledge are carried out on a national scale. Millions of fossils are digitized and entered into open-access databases, serving thousands of research projects globally. Projects like the Digital Atlas of Ancient Life help anyone from elementary school students to university professors explore extinct species with just a click. The future vision is also clearly mapped out, not just to preserve fossils, but to preserve the connection between humanity and the history of life. Experts in the U.S. are collaborating internationally to build a global standard for fossil data, research ancient DNA from fossils to better understand evolution, and even pursue ambitious projects like resurrecting proteins from dinosaur soft tissue. And so, from the golden sand deserts of Arizona to the Great Plains of the Dakotas, from Ivy League institutions to rural classrooms, from electron microscopes to globally broadcast documentaries, the spirit of learning about dinosaurs still burns brightly in the United States, a country that has turned extinct animals into living symbols, not only in science but in the human mind. For America, dinosaurs are not just the past. They are a source of inspiration, a bridge between science and the public, and living proof that as long as passion remains, an entire lost world can be brought back to life, miraculously through human intellect and technology.